Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. Good evening all of you. Yes guys, so this is the third class of this Mastering Concepts for GATE 2023 and the topic is Peterson Solution. So we are going to cover first the turn variable, then interested variable, and then we will be talking about Peterson Solution. So guys, please confirm once whether I'm properly audible and visible to all of you or not in the chat box. And guys, do share this class as much as you can with all the friends and your classmates, those who are going to prepare for this GATE 2023, so that everyone can take the benefit of this class. Yes, am I properly audible and visible to all of you? Kindly confirm once. Then we are going to start today's class. And guys, do like the session, share with your friends as much as you can. So today's topic is Peterson's solution, and we will be solving one question based on this as well. Hi Utkarsh, good evening. Yes, good evening Ikra, thank you. Okay guys, so let's start. And guys, do like the session, share with your friends. So before starting, let me introduce myself. My name is Anshul Sharma. I have 2+ years of teaching experience. In GATE 2020, I have secured All India rank 294. Cleared ISRO and NILET exam, mentored more than 1,000 students as of now, and these are my area of expertise: operating system, digital logic, compiler, and computer organization and architecture. So guys, let's proceed. Now, if you want to get the PDF of all my YouTube classes, so you can join this Telegram group. This is the link, CS_by_Anshul_Sir. And you will be getting all the PDFs, doubt clearances, and also if you need any guidance, then also you are most welcome. Okay. Hi, good evening AB. Okay. So now you can join this group and you will be getting all the PDF of my YouTube classes. Fine. So let's proceed. Shall we start now? Everyone just confirm once in the chat box. Then we are going to start today's topic. First of all, we will be talking about turn variable, and we also call it as strict alternation method. Yes, AB, how to maintain consistency in studies. So basically, if you want to be consistent throughout your preparation phase for GATE exam, then you have to think about your goal, why you started your preparation. That is important here, okay? So you have to ask yourself daily that why you started this preparation, what do you want to achieve from this exam. Okay, if you are going to ask yourself this thing, you will be thinking about your goal more and more, and your focus will be just on this exam only and its preparation, not on other things that is going around yourself. Okay, so that is important. So ask yourself, and definitely it will motivate you and you will be consistent in your preparation. So guys, let's start turn variable or strict alternation method. So first of all, this is also a software mechanism implemented at user node. So in the previous classes, I have explained you, if we propose any synchronization solution and it is a software based, so we can say it is architectural neutral, right? It will follow the property of a condition of synchronization mechanism, the fourth condition, that is architectural neutral. Architectural neutral means it is platform independent, it is not based on any platform. Then if we talk about the second one, that it is a busy waiting solution. It is also a busy waiting solution. So I explained you there are two types of mechanisms. One is a busy waiting solution, other one is blocking, or you can say without busy waiting. So this turn variable is also one of the busy waiting solution, right? Now it is a two-process solution. That means it is applicable only for two processes, not more than two processes. Clear? Good evening Anu, good evening. Then now let's see the code of this turn variable. Now if you see here, there are two processes, process P0 and process P1, and now assume that you have one turn variable which is common for both the processes. So let's say initial value of turn is equal to 0. Initial value of turn is equal to 0. Now we have to find out whether it satisfies mutual exclusion, whether it satisfies progress, whether it satisfies bounded waiting. Okay, so these three conditions we are going to check. If it satisfies all the three conditions, then we can say yes, it is a correct synchronization solution and we can use it. Okay, Now, first of all, we will be talking about mutual exclusion. What is mutual exclusion? No more than one process should be able to access the critical section at a time. That means only one process is allowed. Now, let's schedule this process P0. So, turn variable, initial value is 0, non-critical section fine, while turn is not equal to 0. So, as you can see, it is 0, 0 is not equal to 0. That is a condition of, that is false, right? So, if it is false, your P0 will be able to access the critical section. Now, at the same time, we have to check whether process P1 is able to access the critical section or not. So, at this time, P1 process, let's see here, non-CS part, that is fine. Now, while turn not equal to 1. So, initial value of turn is 0. 0 is not equal to 1. 0 is not equal to 1. This is true. Both are unequal. So, this is true. This is true. So, that means process P1 is going to do busy waiting here. It will be doing busy waiting here. And that means it is going to waste the CPU cycles, which will impact the overall performance of the system. So, busy waiting is done. So, can we say that only at a time, only one process is allowed to enter the critical section? Yes or no? Everyone? So, yes, mutual exclusion is satisfied in this case of turn variable. Now, let's talk about progress. So, I explained you progress, that the definition of progress is, if one process is not interested to access the critical section, it should not stop the other process to access the critical section, right? So, if it is so, then we can say progress is there. Now, let's see progress here. Let's say I'm not executing P0. P0 is not interested to access the critical section, but P1 is interested. Now, if P1 is interested, let's say initial value of turn is equal to 0. Now, you tell me whether process P1 will be able to access the critical section or not. What do you say? So, here initial value is 0. 0 is not equal to 1. It will be true. That means P1 is not able to access the critical section. Why? Because the turn value is 0 and only process P0 can make the value of turn as 1. That means P0 is stopping P1, or you can say it is not allowing P1 to access the critical section because the turn value is 0 and only P0 can make it 1. Is it clear? So, can we say that the progress is not defined? Can we say progress is not defined in this case of turn variable? Yes, everyone. Yes, De Villiers, spin lock and busy waiting same or different? See, busy waiting means this process P1 is keep on executing this infinite loop till it becomes false. That is busy waiting. What is a spin lock? Let me explain you spin lock as well. Let's see here. Let's say we have one process P. Let's say P1 is process there, okay? And in this we have certain condition here, right? Let's say this is your critical section and this is the exit section, okay? Now, P1 is executing this. Let's say another process P2 of higher priority, this is having lower priority. Now, P1 is executing. Let's say P1 is present in the critical section. P2 process of higher priority arrives in the system. So, in this case, if your system is following priority based scheduling algorithm, in that case, what it will do? It is going to preempt the process P1. It is going to preempt the process P1. Now, as this process, let's say here you have the lock variable also. Let's say lock is equal to log is not equal to 0. In this case, let's say log initial value is 0. 0 is not equal to 0. That means it is false. So, P1 is here. Now, if P2 is executing, what P2 will do? What P2 will do? Let's say log is equal to 1. It has made log is equal to 1. Now, P1 will preempt. P1 will get preempted as P2 is of higher priority process, but due to this lock condition, P2 will not be able to access the critical section. P2 will not be able to access the critical section. So, this is a condition of spin lock. Is it clear? AB. Clear? That means if a higher priority process arrives when a lower priority process is already present in the critical section, in that case, the lower priority process will get preempted. CPU will try to give the CPU will be allocated to basically P2 process, but P2 is not able to access the critical section because this lock is not available. P1, as it was present in the critical section, it got preempted. Lock is there with P1, not with P2. That is the condition of spin lock. Okay, I hope it is clear to you. Now let's come back to this topic, turn variable. Now, so as you can see, progress is not defined in case of turn variable. Let's talk about bounded waiting. What do you say? Yes, everyone, what do you think? Bounded waiting is satisfied here in case of turn variable or not? What is bounded waiting? Bounded waiting means there should be a limit on the number of times a process can access the critical section so that other process who is interested should not face starvation. Yes, what do you think? Bounded waiting is satisfied here or not? Tell me. Yes. Now let's talk about bounded waiting here. So if you see carefully, let's say P1 is interested and P0 is there in the critical section. It will make turn is equal to 1. Turn is equal to 1 will be there. Okay, fine. Now it makes turn is equal to 1 and then it executes non-critical section. Let's say P0 again wants to execute it. Okay, let's try. Turn is not equal to 0. Here it is 1. 1 is not equal to 0. This is true now. So in this case, P0 will perform busy waiting. Let's say CPU allocated to P1 process now. So it will check this condition because it was performing busy waiting here. Turn value is 1. 1 is not equal to 1. This will become false. P1 will be able to access the critical section. So that means, as it is clearly written here, that turn variable is also a strict alternation method, right? That means, let's say here, if turn is equal to 0 initially, so the order of execution of processes would be this one: P0, P1, P0, P1, P0 and so on. If the initial value of turn is equal to 1, in that case, first P1 can execute, then P0, then P1, then P0 and so on. That means strict alternation is there. If strict alternation is there, definitely bounded waiting will be satisfied. Definitely bounded waiting will be satisfied. Is this clear to all of you? If you have any doubt here, please ask. If you have any doubt here, please ask, guys. Clear? So here we can see in case of turn variable, yes, strict alteration is there. So here we can see in case of turn variable, progress is not satisfied. So we can say progress is one of the primary condition or one of the primary condition for synchronization mechanism. If it is not satisfied, so it's not a correct solution. It's not a correct solution. So let's proceed to the next solution that was proposed, and it is interested variable. Interested variable. Okay, let's see the code of this one. So here you have fine. Okay, so let's say this is the code of interested variable. You have non-critical section, then you have int of I is equal to true, while int of j is equal to true, critical section, and then you have int of I is equal to false. So this is also applicable for two processes. Let's say you have process P0 here, and let's say you have process P1 here. Now carefully listen this. If I'm executing process P0, in that case I value would be 0 and j value is always equal to I minus 1. That means it is going to be 1 here. Sorry, 1 minus I, not I minus 1, 1 minus I. It is going to be 1 minus I. Clear? If I'm executing P0 process, then I value will be 0 and j value is 1 minus I, that means 1 here. If I'm executing P1 process, in that case I value would be 1 and j value, as it is 1 minus I, so it is going to be 0. Is it clear? That means whichever process I'm going to execute, for that I have to consider the I value, and for the other process it will be j value. Is it clear? Is it clear to all of you? Now carefully see this. Let's say I'm executing P0 process and there is one interested variable, or you can say the array basically. So int of I is equal to true. So let's see here, int of 0. If I'm writing int of 0, that means I'm talking about P0 process. That means I'm talking about P0 process. Yes or no? So initially this is false. That means P0 is not interested. Similarly, if I'm writing int of 1 is equal to false, that means initially P1 is also not interested. P1 is also not interested. Yes, Utkarsh, in previous slide I didn't get process P1, sir. Okay, wait, let me explain this one, then I will take your doubt. Okay. Now carefully see this. If I execute P0 process now, non-critical section, int of I is equal to int of 0 is equal to true. That means we have to make the P0 process interested for the execution. Fine. Now while int of j, so when I am executing P0 process, int of j would be int of 1. So if it is equal to true, that we need to check. Then we have the critical section, and int of 0 will make false. Okay, we are going to make it false. Now if I talk about P1 process, so let me write the code first. In that case it will be easy for you to understand it. So here we have the non-critical section, then we have int of 1. Int of 1 is equal to true. Then we have while int of j, that means for P1 it is going to be 0. If it is equal to true, then it is a critical section, and then you are making int of 1 is equal to false. So this is the code. This is the code for P1. This is the code for P0. Now carefully see this. Now carefully see this. I'm executing P0 process. Int of 0 is equal to true. Okay, now P0 is interested. So first of all, we are going to check the condition of mutual exclusion. Fine. So int of 1, is it equal to true? It is going to check, but it is false. So false is equal to true? No, that is false. That means P0 will be able to access the critical section at this time. Is it clear? Now if P0 is already there in the critical section, let's check whether P1 will be able to access the critical section or not. Int of 1 is equal to true. Fine. Make P1 process also interested for the execution. Int of 0 is equal to true. Int of 0 is true. True is equal to true. Yes, it is true. That means P1 process will do busy waiting here. P1 process will do busy waiting here. Is it clear to all of you? Is it clear to all of you? So can we say mutual exclusion is satisfied in case of interested variable? Because at a time you are only going to have one process present in the critical section. Now if you have any doubt so far, please ask. Anyone having any doubt here? Yes, all clear so far? Yes, do respond in the chat box so that I can proceed further. Yes, Ikra, Anu, Utkarsh, AB. So let's talk about progress now. So if I talk about progress, let's say P0 is not interested to access the critical section. Let's say if P1 will be able to access it or not. Yes, why int 0 is equal to true? Because I is equal to 0. So why int 0 is true? क्या पूछ रहे हो उत्कर्ष? Int of 0 means it is for P0 process. Initially it is false. That means P0 and P1 both initially they are not interested. Then when we are executing P0, we made it true. That means now it is interested. Okay, I hope it is clear now. Okay, so now let's talk about progress. So suppose I'm not executing P0. Let's say if I'm able to execute P1 or not. So int 1 is equal to true. Okay, let's make it true now. Fine. Int 0 is equal to true. Let's say it is initially false only. So false is equal to true. That is going to become false. So in that case, P1 will be able to access the critical section. That means progress is there as of now. It seems, again I'm repeating, it seems that progress is satisfied in this case. Okay. It looks like as per the given method that we know that progress is satisfied. But if you carefully observe here, let's take one more case. Let's say P0 executes, int of 0 is equal to true. It makes it true. Let's say it got preempted after that. Okay, let's say P0 got preempted. Now int of 1 is equal to true. Okay, we made it true. Now let's say int of 0 is equal to true. So true is equal to true. That means this condition will be true. P1 will be doing busy waiting here. Similarly, now if I execute this one again, int of 1 is equal to true. Yes, it is true. P0 will also do busy waiting here. So that is a condition of, that is a case of deadlock. That is a case of deadlock here. So can we say we have a deadlock? We have the possibility of deadlock in this case, yes or no? So if there is possibility of deadlock, can we have progress satisfied? No. So in this case, due to deadlock, say in most of the resources online, if you refer, you will find it out that in case of interested variable, they say progress is satisfied. But as we know the concept that if deadlock is there, progress is not satisfied. Yes or no? Everyone agree? If deadlock is there, progress is not satisfied, and we can see clearly that we have the case of deadlock when P0 executes this statement and got preempted, and then P1 executes this one. So both the processes will not be able to execute further. In that case, deadlock is there, and we know if deadlock is there, progress will not be there. Okay, is it clear so far? If you have any doubt here, please ask guys. And then we will be talking about this bounded waiting. Then we are going to talk about bounded waiting. All clear? Okay. So let's say this bounded waiting. Now, do we have bounded waiting here? Now, if you see here, let's say P0, okay, let me take it again, this one, int of 0 is equal to false. Okay, because here we are not going to understand it. Already we have taken few cases. Int of 1 is equal to false. Initially both are, let's say, not interested. Now bounded waiting means, let's say we are going to try to execute P0 again and again if P1 is interested. Okay, yes, it is not deadlock free. Now let's execute. Int of 0 is equal to true. Let's make it true. While int of 1 is equal to true, that is false. False is equal to true. No, false. P0 is there. Now let's say at the same time P1 got interested. When P0 is present in the critical section, let's say P1 is also interested. Okay, so what P1 will do? It will make int of 1 is equal to true. That means it is going to show its interest. Now let's say P0 executes int of 0 is equal to false. Okay, here we are doing right. Int of 0 is equal to false. Int of 0 is equal to false. And now see, P0 can execute again or not. So int of 0 is equal to true. Fine, true. Int of 1 is equal to true. Yes, it is true. So true is equal to true. P0 will do busy waiting now. That means P0 is not able to execute again. It will be doing busy waiting here. Let's talk about P1 now. Int 1, that is already executed. Int 0 is equal to true. Yes, it is true. So P1 will also get blocked. That means this is a similar case of deadlock here. Where none of the process is able to proceed when other process also show its interest to access the critical section. So can we say bounded waiting is also not satisfied here? Bounded waiting is also not satisfied in case of interested variable. In case of progress, you will see on many resources, again I am repeating that they will mention that progress is satisfied, but no, that is incorrect. If you have deadlock, there will be no progress. Because progress, we talk about the whole system, we talk about progress in terms of whole system, we talk about bounded weighting in terms of a process. Okay, per process we talk about bounded weighting, but in case of progress we talk about the entire system, whether the system is able to proceed or not. Clear? So that is why if deadlock is there, progress is not there, but bounded weighting is also not satisfied in this case. So this was this turn variable and interested variable, both were a failure solution, we can say. Now we are going to talk about Peterson solution. So Peterson was a scientist who came up with an interesting solution. Basically it merged turn and interested variable solutions both, and then we will see how it is going to satisfy all the conditions. Yes, Utkarsh. Int 1 is true, so P1 is blocked. Yes, int 1 is true na. Int 1 is true, so here this will also do busy waiting because int 0 is true. So both the process will do busy waiting here. That means none of the process is able to execute further. Yes. Now let's see the Peterson solution. So if you talk about Peterson solution here, let's see the code. So before seeing the code, just a minute. It is also a software, I'm sorry. Wait. Yeah. It is also a software mechanism implemented at user mode. So like we have seen turn variable and interested variable, similarly Peterson solution is also a software mechanism. That means it is architectural neutral. Then it is also a two process solution. So you can consider this as one of the disadvantage, that we cannot use Peterson solution for more than two processes, because in real time we can have multiple processes, right? We can have hundreds of processes running simultaneously or concurrently, and we need to maintain the synchronization between those processes. So we can consider this as the disadvantage, that it is only applicable for two processes. Clear? Then it is also a busy waiting solution. So if it is a busy waiting solution, it is going to impact the performance of the system because CPU cycles will be wasted. So this is also one of the disadvantage you can consider. Now let's see the code of Peterson solution. Okay, so this is the code of Peterson solution, and again we are going to check all three conditions. Mutual exclusion, we will be talking about progress, and we will be talking about bounded weighting. Okay. So now if you carefully see, first of all let's talk about mutual exclusion. Let's say we have one process P0, right, and we have one process P1. Fine. Here also we are maintaining one flag of array. So flag of I is equal to true. That means if P0 is executing, I value is equal to 0 and j value is equal to 1 minus I, that means 1. Okay. Similarly, if P1 is executing, in that case I value would be 1 and j value would be 1 minus I, that is 0. So j value indicating the other process when one process is executing. Clear? Here we are maintaining, so this flag you can consider as int of I, that means the interested variable, and turn variable, both it is using. Clear? Carefully understand here. So turn is equal to j, while flag of j and turn is equal to j, critical section, then flag of I is equal to false, remainder section. Now let's execute this code. Let's talk about P0 now. So initially, let's say flag, I'm writing flag of I, that means flag of 0 is equal to false. Okay, initially none of the process is interested. None of the process is interested. Fine. Let's say P0 wants to execute this, and we are checking. Yes, that is correct. Like Nishu, if P0 is executing, so we have to consider the subscript, sorry. That is correct. Okay. Okay, now carefully see. We are executing P0, fine. Flag of 0, it is going to make it true. So let's say here it is false. Let's make it true. Fine. Turn is equal to j. Okay, so there is a turn variable which is common for both the processes. Turn is equal to 0. If I'm executing P0 process, I value is 0, J value is 1, so turn will be 1. Turn value will be 1. Now, while flag of J, that means if I'm executing P0, it is indicating towards P1. Flag of J, that means flag of 1 is false. And here you can see there is a AND operator. So both the conditions have to be satisfied, right? If any of the condition is false here, in that case this while loop will break and the process will be able to access the critical section. So flag of J is false, one condition is false, we don't have to check the other condition because both have to be true. But here it is false. In that case we can say P0 is present now in the critical section. It is able to access the critical section. Yes or no? Are Utkarsh, initially we are considering that flag is false for both the processes, flag of 0, flag of 1. That means none of the processes is interested initially. Okay, yes. Now so P0 now it is present in the critical section. Let's try to execute P1 process and see and check whether mutual exclusion is satisfied here or not. Let's execute P1 process now. So if I execute P1 process, flag of I is equal to true. Let's make it true because for P1 I is 1. So flag of 1 is equal to true. Turn is equal to J. Turn is equal to J. That means if I am executing P1 process, J value will be 0 here. So turn will be equal to 0. Turn will be equal to 0 now. While flag of J, so for J that means flag of 0. Flag of 0 is what? Flag of 0 is true here. Flag of 0 is true here. That means this condition is true. And turn is equal to J. Turn is equal to J. Yes, it is also true because J is 0. So turn is equal to J. This is also true. Both the conditions are true. Busy waiting will be done by this P1 process. It will keep on doing busy waiting now. So can we say that mutual exclusion is satisfied? Only one process is able to access the critical section at a time. Yes or no? Everyone? Now if you have any doubts so far, please ask. If you have any doubt in this mutual exclusion, please ask. Because this is important. Peterson solution is important. Turn an interested variable. We understand it, we discuss it because Peterson solution is based on turn an interested variable. But this is important, so try to understand everything. And if you get any doubt here, please ask. So mutual exclusion is satisfied. Now let's talk about progress. So now if I talk about progress, so as we can see, let's say if P1 is not interested, we were able to access the critical section P0. Similarly, you can take vice versa also. If P0 is not interested, P1 will be able to access the critical section. Why? Because flag of I is equal to true. So I, that means this is going to be true. Fine. Turn is equal to J. Turn will be 0. Flag of J, this is false because if I am executing P1 first and P0 is not interested, then flag of this will be false. P1 will be able to access. That means both ways. You can say vice versa, it is true. That means progress is satisfied. No process is stopping other process to access the critical section if it is not interested. That means progress is definitely satisfied here. Now if you have any doubt in this point also, please ask. Yes, anyone having any doubt? Then we are going to talk about bounded waiting here. How bounded waiting is satisfied, that is the main crux. That is the main crux of this Peterson solution. Because in interested also we saw that bounded waiting is not satisfied. In turn also we see that bounded waiting is not set. Bounded waiting is satisfied, but in interested it was not satisfied. But now we are going to see how bounded waiting is satisfied in case of Peterson solution. This is the main part. So before proceeding to that, please confirm once in the chat box that everything is clear so far, whatever we have discussed here. Yes, all of you. And guys, do like the session if you haven't liked it yet. All clear? Okay. Let's talk about bounded waiting now. let's talk about bounded weighting now. Okay, thank you, Nishu. Let's talk about bounded weighting now. Now, how bounded weighting is satisfied, you need to observe one thing here. You need to observe one thing in Peterson solution here. Whichever process executes turn is equal to j first, this statement, whichever process, whether P0 or P1, executes turn is equal to j first, that is going to enter into the critical section first. That is going to execute the critical section first. Now carefully see how. Okay, so let me take this case again so that I can make you understand how bounded weighting is satisfied. Okay, so here we have, let's say, P0, and here we have, let's say, P1. Flag of 0, let's say it is false. Carefully listen this thing. Okay, flag of 0 is equal to false, and here flag of 1 is equal to false. Fine. Right, now see this. Let's execute P0 first. So what will happen? Flag of I is equal to true. So flag of I, that means flag of 0 will be true. Fine, it is true. Let's say P0 is executing this statement, turn is equal to 0. Turn is equal to j, sorry. Turn is equal to j. For P0, j value is 1, turn is equal to 1. Now, let's say P0 got preempted just after executing this second statement. Just after executing this second statement, P0 got preempted. Fine. Now let's come back to this P1 process. Let's say it is also interested. So flag of I is equal to true. It is going to show its interest. Fine. Turn is equal to j. Okay. So for P1, turn value will be 0. For P1, j value will be 0. No, Ikra, alternation, strict alternation is related to bounded weighting. Okay, if we have strict alternation, then we can say bounded weighting is satisfied. But only, if strict alternation is not there, then also we can have some cases where bounded weighting is satisfied. So alternation, strict alternation is not related to progress at all. In progress, what you have to see is, if I'm not interested to access the critical section, if I'm not interested to access the critical section and you want to access the critical section, I won't stop you to access the critical section. Okay, I won't stop you. So that is progress. Similarly, vice versa should also be true. If I'm interested and you are not interested to access the critical section, then you won't stop me to access the critical section. This is what we have is progress. Okay, I hope it is clear now. Okay, now carefully see this. And how we can show the interest? So using this one we are or we can say the process is showing its interest, that whether if it is making its flag value true, that means that process is interested to access the critical section. Clear? Now let's come back to this bounded weighting concept. Turn is equal to 0. So we executed P1 then, and flag of 1 is equal to true, then turn is equal to j. So for P1, j value is 0, so turn will be equal to 0 here. Turn will be equal to 0 here. Clear? Now, let's say P1 is continuing its execution. While flag of j, is it true? Yes, it is true, because flag of j is 0, flag of j is true. This is true, fine. And turn is equal to j. Turn is equal to j. Yes, turn is equal to j. That means both are true. Busy waiting will be done. It will be doing busy waiting here. P1 process is not able to access the critical section. Is it clear? Is it clear? So P1 will not be able to access the critical section. Why? Because P0 executed this statement first. Turn is equal to j. It executed this statement first. This is the reason. Now let's say P1 is doing busy waiting here. Let's come back to P0. Okay, for P0, it will be executing this while loop now. Flag of j. So flag of j, yes, it is true. Because for P0, j is this one, right? Flag of j is true. Fine, it is true. Turn is equal to j. No, turn is equal to I here, because for P0, I is 0. So turn is equal to 0 here. This is going to become false. Any of the condition is false. P0 will be accessing the critical section. So this is the main crux of Peterson solution. Whichever process is going to execute this statement turn is equal to J, that is going to first access the critical section no matter what. This is the main thing here in Peterson solution. So this is the main statement. Now your doubt should be, sir, we understood this point. Whichever process is going to execute turn is equal to J, that is going to execute the critical section first. But how bounded waiting is satisfied? How bounded waiting is satisfied? Now carefully see. Now carefully see this. P0 is here in the critical section, fine. Flag of I is equal to false. Flag of I is equal to false, fine. False here. Remainder section, fine. Let's say P0 executes again. P0 wants to execute again. Now carefully see this. Flag of I is equal to true. What P1 is doing? P1 is still doing busy waiting, right? Now flag of I is equal to true. Let's make it true. Fine. Flag of I is equal to true. Turn is equal to J. Turn is equal to J. P0 is executing now. Turn is equal to J. Turn is equal to J. That means for P0, J value is 1. So turn is equal to 1 now. Let's say P0 is executing this while loop now. Carefully see this. Flag of J. Flag of J. Flag of J, if P0 is executing, J means 1. So flag of J is already true, right? P1 is there now, so it is already interested. So this is true. And turn is equal to J. Turn is equal to J. Turn is equal to J. Yes, it is true. For P0, J value is 1. Turn is equal to J. So it is 1. That means now P0 will also be doing busy waiting here. P0 will also be doing busy waiting here. Is it clear so far? Everyone? Now, as P0 is doing busy waiting here, let's come back to P1 now. P1, let's execute this while statement. Let's execute this while statement. Flag of J. For P1, flag of J, that means flag of 0. Yes, it is true. Fine, it is true. And turn is equal to J. Turn is equal to J? No. Turn is equal to I, because for P1 I value is 1, turn is equal to 1. This will become false here. This while loop will become false here. It will break and P1 will be able to access the critical section. So how bounded waiting is satisfied? So if you remember everything, first P0 executes the turn is equal to J. It got the chance. Then P1 executes turn is equal to J. It was doing busy waiting. As soon as P0 gets out and tries to execute again this while loop, P0 got stuck here. It is performing busy waiting. But P1 got the chance now, because after P0, P1 executes this turn is equal to J. That's why P1 is present in the critical section now. So whichever process is going to execute turn is equal to J statement first, that is going to access the critical section. But after that, let's say P1 executed that, so P1 only will get the chance after that to access the critical section. That is why bounded waiting is satisfied here. That is why bounded waiting is satisfied here. Is it clear to all of you or not? Please let me know this. This is the main concept of Peterson solution. Everyone can explain you mutual exclusion, progress, but this bounded waiting is the main thing that most of the I would say most of the people, they get confused and they are not able to give the proper explanation. Is it clear now? If you have any doubt here, please ask. Yes, Nishu, clear? Okay. What about others? Ikra, Utkarsh, Anu. Let me know if you have any doubt here. So it is satisfying all the necessary conditions, all the important conditions of synchronization mechanism. So in your notes, you can write it down. Whichever process is going to execute turn is equal to J, that is going to access the critical section first. Okay, this is the main thing in Peterson solution. And on the basis of this only, bounded waiting is satisfied. Clear? And it is also architectural neutral, because it is a software based solution. So it is also architectural neutral, that means platform independent. Okay. Now I have one question for you. That is only the one question we are going to solve today, and then it is over. Now I want you to answer this question. Everyone, answer this question now. I hope it is visible. Let me just be here. Okay. This question, this is a previous year question and it is based on Peterson Solution only. Tell me what should be the answer here. And guys, do share these classes as much as you can, all the classes that I have taken in this series, so that many students can get the benefit, those who are planning or those who are going to start or those who have already started the preparation for GATE 2023. Tell me what should be the answer for this one. If you see carefully, everything is same. This is just the algorithm, this is just the pseudo code for this one, Peterson Solution only. You just have to find what will be this predicate P. What should be there in this while loop. What should be the condition in the while loop so that this will guarantee mutual exclusion. The same thing that we had in Peterson Solution, right? Okay, let's see this question now. Consider Peterson's algorithm for mutual exclusion between two concurrent processes I and J. The program executed by process is shown below. For the program to guarantee mutual exclusion, the predicate P in the while loop should be what? So we know this flag of I is equal to true, turn will be equal to J. These two statements we know. What should be there in the while loop? That is going to be flag of J, because it checks whether flag of J is true or not and turn is equal to J or not. Yes or no? If not, you can see here also flag of J is equal to true or not, turn is equal to just a minute. Yes, turn is equal to J or not, flag of J is equal to true or not. Clear? Yes, I got it, Ikra. Okay, so we can see here that only option B is the correct answer. Flag of J is equal to true and turn is equal to J. Clear? If this is the condition we are going to have in the while loop, then definitely it will guarantee mutual exclusion. Okay, it will definitely guarantee mutual exclusion. So option B is the correct answer. Directly they ask questions based on Peterson Solution. Directly they have just given the algorithm, or you can say the pseudo code for this. Clear? All clear so far? So that's it, guys. From this class we covered turn variable, interested variable and Peterson Solution. In the next class, that is tomorrow, we will be starting semaphores, binary and counting semaphore. We will be solving questions also, and first I will explain you the concepts for both the semaphores. Clear? If you want to get the PDF of this class, you can join this Telegram group. Okay, you can just search it in the search tab of Telegram. You will be getting PDFs of all my YouTube classes, doubt clearance, and if you need any guidance related to your preparation, then also you are most welcome. Fine. So that's it from this class. I will see you tomorrow. And one more thing, tomorrow at 6 PM I will be taking DLD class, that is part 2 for BARC and HAL, and 8 PM I will be taking this OS class, okay, where I will be explaining you semaphores. Fine. So thank you, and do subscribe to BYJU'S Exam Prep YouTube channel so that you don't miss any notification, and also join the Telegram group so that you stay updated for all my classes. Thank you all of you. Good night. Take care. I hope you have enjoyed this class. Thank you so much. We'll see you tomorrow. Good night and take care. Bye-bye. Thank you all. Bye.